Okay, let's dive into this engineering case study. We're looking at the real-world problems of building a transactional AI agent for a company we'll call SkyStream Airlines. And just to be clear, this isn't about AI hype. This is about the hard, gritty engineering reality.
So here's the situation on the ground. SkyStream is bleeding cash, and this number right here is the reason why. The average customer hold time is a staggering 45 minutes. As you can imagine, that has absolutely tanked their Net Promoter Score, and it's putting a massive strain on the whole business. The pressure is on.
So, the mandate comes down from the top. The executive team wants an AI agent to fix this whole mess, and they want it yesterday. But here's the thing. There's a really dangerous assumption baked into this request, that it's just a matter of, plugging in GPT-4 and letting it talk to customers. As we're about to see, it is anything but that simple. Before we even think about writing a single line of code, we have to start with the legal reality. Because for engineers and product managers like us, this whole space is a minefield. And a recent court case set a very, very expensive precedent that pretty much defines our entire project.
Now, you have to see this. When Air Canada's chatbot gave a customer bad info about a refund, the airline actually went to court and argued that the chatbot was a separate legal entity and was responsible for its own words. I'm not kidding. The court, to put it mildly, did not agree and held the airline completely liable. So, what's the bottom line for us at SkyStream? It's this. Accuracy is not a feature. It is a binding legal and financial requirement. If our AI agent makes a promise, the company is on the hook to pay up. Period. Okay, so that legal risk gets even scarier when we look at the core technical problem, which is really all about this massive friction point between the customer and the airline's own systems. So forget that simple idea of a user talking to a model. What we're actually building is a bridge across this huge gap. On the left side, you've got the user. They represent chaos, natural language, they're mad, they're confused, they're emotional. And on the right side, you've got the hard reality. That's order, rigid systems, and legacy mainframes. That's the chasm we have to cross. And this brings that friction point into really sharp focus. A user is yelling in all caps, "Change my booking, no fees." But the airline's global distribution system, a mainframe that might be decades old, it only understands these cryptic codes. The AI's job is to translate that chaos into this rigid order perfectly every single time. Any mismatch is a potential catastrophe. And that hard reality isn't just one system. It is a whole web of painful constraints. You've got the GDS mainframe that demands perfect syntax. You've got a database of policy documents, probably just a folder of PDFs with conflicting rules from different years. And of course, you've got the payment gateway, which has absolutely zero tolerance for any kind of error. Now, on top of all the legal and technical hurdles, there's a third layer of risk. And this one is a non-negotiable hard stop from regulators. As of 2024, the U.S. Department of Transportation has a very clear rule. For certain situations, like a canceled flight or a major delay, airlines are legally required to give customers a prompt and automatic cash refund. Not vouchers, not credits, cash. This creates a huge failure mode for our AI agent. See, an LLM's natural tendency is to be helpfully persuasive. It might try to negotiate with a customer or offer a travel voucher to keep the revenue. But if it does that when the user is legally entitled to cash, our agent has just pushed the company into violating federal law. So, when you stack up the legal liability, the technical friction, and these regulatory hard stops, it forces us to completely reframe the engineering problem. We have to shift our focus away from the AI itself. And this right here is the key takeaway. Our main job isn't about making the large language model more intelligent or creative. Our core engineering challenge is building robust guardrails, the tools, the parsers, the safety checks that contain the model and prevent it from causing a catastrophe. When you break it all down, our agent needs three things. It has to be empathetic to calm down an upset customer. It has to be deterministic to follow the law and the system rules precisely. And it's got to be secure. The problem? Well, base LLMs are actually great at number one, but they are fundamentally terrible at being deterministic, and they're incredibly risky when it comes to security. And this leaves us with the one central question we have to answer before we let an AI loose in a high-stakes environment like this one. We know we can make it sound empathetic, but can we guarantee that it will be deterministic? Because in the world of transactional AI, preventing a single catastrophe is infinitely more important than 1,000 helpful conversations. That is the real engineering challenge.